how long does it actually take you to produce a single architectural perspective between setting up V-Ray, Lumion, or Enscape, dialing in the lighting, iterating on materials, pushing revision after revision? Half a workday disappears before the image is even close to ready. And yet, right now, architecture firms across the globe are compressing that entire process down to 8 minutes. The key is ControlNet. This is not a simple image generation tool. It is a technology that preserves your drawings and sketches exactly as designed, then transforms them into photorealistic renderings. In this video, we will break down a complete ControlNet architectural visualization strategy, everything you need to apply it in professional practice, starting today. Let us start with the fundamentals. ControlNet is a technique published in 2023 by researcher Min Zhang, developed in collaboration with Stanford University. It works by adding a structural conditioning layer on top of Stable Diffusion. Standard image AI models generate visuals purely from text prompts, which means the output shifts every time, and the precise spatial structure an architect requires tends to collapse. ControlNet takes a fundamentally different approach. It feeds structural data, edge outlines, depth information, surface normals directly into the generation process alongside your written prompt. The result, your floor plans, 3D wireframes, and hand sketches are preserved as the spatial skeleton, while the AI fills in materials, lighting, and atmosphere. The designer's intent remains intact. The expressive range expands dramatically. It is the difference between generating a building and generating your building. Within ControlNet, multiple models serve different purposes. Here are the 4 you absolutely need to understand for architectural practice. First, Canny Edge. This model extracts only the outline of your image and passes it to the AI. Feed it a scanned floor plan or elevation drawing, and the result preserves your line structure with high fidelity. It carries the lowest barrier to entry and is the best starting point for most practitioners. Second, depth. This converts spatial depth into a grayscale map. It is exceptionally powerful for interior perspectives, where you need convincing 3-dimensional recession across the full depth of a room. Third, normal map. This encodes surface orientation data, enabling finely detailed material expression, exposed concrete textures, brick relief, and rough stone surfaces. All benefit significantly from this model. Fourth, MLSD. This model extracts only straight lines, capturing the precise vertical and horizontal geometry that defines modern architecture. It is the strongest choice for minimalist and contemporary building renderings. Now for the core skill. What does a well-structured architectural rendering prompt actually look like? Every effective prompt must contain 4 distinct building blocks. Block 1, space type. Define the space clearly in architectural terms: modern residential living room, minimalist office lobby, or industrial loft with exposed structural steel. The more precisely you specify building use, style, and spatial character, the more accurately the output aligns with your design intent. Block 2, materials and finishes. List the floor, wall, ceiling, and glazing materials using specific architectural vocabulary: exposed concrete, white oak flooring, floor-to-ceiling glazing, brushed stainless steel. Vague material descriptions produce vague results. Block 3, lighting conditions. Describe the light source, direction, and color temperature together: golden hour sunlight through east-facing clerestory, overcast diffused daylight, warm artificial lighting at dusk. Block 4, quality directives. Close every prompt with photorealistic, 8K, architectural photography, shot on Hasselblad, to push output quality 1 level higher. And for your negative prompt, always include blurry, distorted, unrealistic proportions, cartoon. Once you understand the prompts, the next step is designing a repeatable production pipeline. Here is the 3-stage workflow validated in professional practice. Stage 1, structural extraction. Build your model in Rhino, SketchUp, or Revit. Then export a wireframe view as a PNG. This image becomes the structural input for ControlNet, the spatial skeleton your AI will render in full detail. Stage 2. ControlNet configuration. Open the ControlNet tab inside Stable Diffusion Web UI. Upload your extracted image and select your model. The critical rule: always match the preprocessor to the same model family. Canny preprocessor pairs with the Canny model. Depth preprocessor pairs with the depth model. Mismatching them degrades structural fidelity significantly and is the most common setup error. Stage 3. Iterative refinement. Adjust denoising strength between 0.6 and 0.8 to find the balance between structural preservation and creative variation. For client presentation deliverables, a setting of 0.65 maintains strong spatial fidelity. For early-stage concept exploration, push toward 0.8 to allow the AI more interpretive freedom. So how widely is this actually being used in practice? A 2024 industry survey of small and mid-sized architecture firms in South Korea found that approximately 38% of respondents had already integrated AI rendering tools into their production workflow, and of those, 61% specifically relied on a ControlNet-based approach. What makes these findings particularly instructive for a global audience is the top-ranked benefit that adopting firms reported. It was not rendering speed. The number one advantage was improved client communication quality. By rapidly visualizing multiple design alternatives in the earliest stages of a project, firms found that clients made decisions faster and requested fewer mid-process revisions. This pattern echoes adoption experiences reported at firms in Europe and North America. The technology does not replace the designer's judgment. It dissolves the language barrier between architect and client. The sketch becomes legible to a non-technical audience long before construction documents are ever produced. ControlNet is not a technology that erases the architect's sketch. It is, in fact, the most powerful amplifier that first line you drew on paper has ever had. You determine the structure of the space. The AI proposes an unlimited range of material choices, lighting conditions, and spatial atmospheres. The hours you reclaim from rendering become hours you can invest in better design thinking. To recap what we covered today: how to select the right model, Canny, depth, or MLSD, for your specific drawing type, the 4-block prompt structure built around space type, materials, lighting, and quality directives, and the 3-stage workflow from structural extraction to iterative refinement using denoising strength. If this video was useful to you, leave a like and subscribe to stay updated, and drop a comment below. We want to hear how you are applying these tools in your own work.